Allow me to show you a few things about constructors. I'm going to make a class. Let's call it farm. And no farm is complete without a cow. So here's a cow right there. CTOR tab tab and CW tab tab. It's right line cow constructor. And I actually want to do a name here, not a namespace. I want to do a name. And right here, let's say string name. I will pass in the name of the cow and announce the cow's name right there. So here's cow. Cow 1 gets new cow. Let's bring Betsy back into the picture. You've seen her in other videos. Cow 2, new cow. Here's Georgie again, like so. And then let's give the farm a constructor. Let's say farm, like that. All right, so cow constructor traces. Right here, says, hey, I'm constructing myself, here's my name, and the farm constructor traces itself as well. Let's go down to main here and actually instantiate a farm. Alright, what will the output be? Pause the video, think about it. Alright, let me run this. Control F5. Look at that. Cow Betsy, cow Georgie, and farm. Alright, and it looks like it almost ran in the order that I type these in. We have Betsy, Georgie, and farm down here. If I take farm and I move it up here, do you think that's going to change anything? Let's put it above our cows instead. Hopefully you do not expect anything to change. All right, we have nice defined behavior defined by the C# language saying, hey, we will run the constructor calls of these things out here first, and then we will run the farm constructor like so. Something should really rub you wrong about this code right here. You're probably so used to using C# and using some features that I would have highlighted in here that it's just kind of second nature. Yeah, sure, whatever works, it makes sense to me. But there's actually something a little weird about what I've just highlighted here. In fact, let me be a little more specific. There's something a little weird in what I just highlighted right there. Okay, can you identify what that is? What if I came to you, let's go here and say for in I less than 10, CW, hello world. Alright, say we're beginning programmers, we're trying to do hello world in a for loop. Alright, in my teaching time, I've seen students come to me with code that looks something like this. Let me try to bring that out a little bit. Shift tab to back that up. Control Shift S, save. Anything weird? Anything look weird now? Alright, I hope you're looking at this saying, Jamie, you got code here, but it's not inside of a method. Don't you need to put code in a method? Well, I got code here. Alright, is this not a constructor? It's a method that I'm invoking, and new is an operator. Okay, new goes out to the heap and gets some room and invokes the constructor method for us, and then, hey, we even have assignment going on here. All of this that I've highlighted there is code. Alright, so why can't I just dump some code out here and just run it? Just run it. Well, I can't. Alright, the classes are made to hold code inside of methods and data. And here we're kind of mixing our data with our code. Yeah, the compiler obliges and says that's fine if you want to do that. I will just run these constructor calls at the beginning of any constructor you call the outside type, which is farm. So I'll run these cow constructor calls for you in the order that you type them, starting with the first one and then working my way down. Alright, well, how does the compiler do that? It changes your code for it. It's syntactic sugar. Just takes that out. Alright, back that up, put that there. Paste it right there. Cow 1, cow 2. I said 2. Alright, semicolon. Alright, now run this. You can see, hey, the output is identical. Betsy, Georgie, farm. And I can even prove this is the case. Let me Control Z back to where we were at. Put all that down there. Control Shift S. Remember, I have this batch file, which will compile our file back here, and then give me the .NET reflector, so we can further examine it. Go here. Here's our farm constructor, and hey, look at that! Look at that. That's not inside our constructor here, yet it is in the actual compiled version. In fact, if I click on farm, you see, hey, there's no assignment, right? Because the compiler moved it here inside the constructor. So there you go. Let's add another class. Let's call it Jamie's Farm, which will inherit from farm. And give myself a constructor as well. CW, Jamie's Farm, prin. And then right here, I want my own cow as well. Jamie's cow. New cow, we'll call this cow Bessie. Alright, now, what's the output going to be? Let's change this to Jamie's Farm. Okay, what will the output be? I highly encourage you to pause the video and think about it so that you can learn something. Okay, let me run this. Control F5, and voila! Bessie, Betsy, Georgie, Farm. Look, there's Jamie's cow, and then here's the farm's cows, and then the farm constructor, and then Jamie's constructor. This is actually the defined order. Notice all of the embedded constructor calls, meaning these guys right here and this guy right here, all of them, doesn't matter what class they're in, whether they're base type, derived types, all the way down, all of them are instantiated first, right? And then we run the base type constructor and then the derived type constructor. Now, any idea why the C# designers chose this behavior? It's actually different in C++. Well, C++ is a lot different actually, but any idea why they would have chosen this? I believe the reasoning is, hey, inside my constructor, Jamie's farm constructor, or the farm constructor, I could call virtual methods in farm that would invoke things down here in the derived classes, and maybe those methods would rely on these things happening first. Okay, or let me just simplify that even more. If I'm instantiating Jamie's farm, in here I would expect this to happen first, so that I can rely on that state if I needed to, while the constructor executes. You know, I know I have a cow instantiated there. Syntactically, it looks like to me as a programmer, I've created it. It should be created by now. And so there you go. The C# designer said, you know what, let's just all embedded constructor calls or code like this. Let's run that first. And then we'll go from the base type, which makes sense. I need to build the foundation of my class or my house before I build anything on top of that. So that makes sense. Let me get command prompt back up here. I want to show you how this works. Again, we will see that this gets embedded in here. Let me scroll in here a little bit. The compiler will take this and just put it in here. But then it's going to mix that with calls to the base class constructors. So let me bring that back up. C, main class, like so. I'm looking for Jamie's farm. Let's look at my constructor here. Right, in C#, it looks like, yeah, all is well. Jamie cow created, but we don't see that with the base class constructor. So I'm going all the way down to the missile level, the Microsoft Intermediate Language level. Hey, look at this. Look at this. We load Bessie up here. We construct my cow. Right, and then we set a field. And then look at this. Load arg0. This is the base class constructor call. All right, and then we get down to actually doing our own code that we wrote inside of our constructor for Jamie's farm. Alright, so here we go. Embedded data members, the farm class constructor, and then my own constructor code. Now remember the farm class constructor though, what's the first thing it's going to do? Well, let's again go look at the farm class constructor. It creates Betsy and Georgie. Alright, remember we had Bessie and then Betsy and Georgie. Well, Betsy and Georgie are created because we invoked the base class farm constructor, which embedded those calls into there. So anyway, hopefully, I hope that's helpful to know that, hey, yes, the compiler will set up state for you. Yes, go ahead, write some code inside of the class, even though that's kind of awkward. And it will be what you expect it to be, because that's what we defined it to be.